Okay, so welcome to today's class. My name is Tutor Juma. To those who don't know me, I tutor you mathematics and biology. Okay, and some days I can tutor you in other courses. So in today's class, we'll continue with the revision for mathematics 1100/1120 test 1 preparation. So without wasting much of time, we'll go ahead in today's class. Okay, so feel free to ask questions where not clear and I'll be able to respond. Okay, so our first question of today, it is asking us to say, use the laws of algebra of sets to simplify the following expressions involving what? Sets. So we have I, which is A minus, open brackets, B minus A, and then we have Roman numeral number 2, which is open brackets, which is the major bracket. Then there is an inside bracket, which is A intersection B, and the complement, which is outside, union, open brackets, A minus B, close brackets, and then the main brackets, then complement outside. So this is the first question we are supposed to solve. So the first thing you're supposed to do when you have this question, you have A or you have I. So we have I, which is A minus B minus A. Okay, so when you have this question, the first thing you have to start with, it is to start with what is in the brackets. So according to the rules that we learned about subtraction, when we have, for example, a set which is A minus B, this is just the same as writing it as A intersection B complement. Okay, so meaning that here it is just the same. We have A minus what is in the brackets, which is B intersection A complement. That is what we have. So after we have expressed this, now we go with what is outside. So what is outside? We have A minus open brackets B minus A intersection A or B intersection A complement. So now this is one set. So you are subtracting this set from A, meaning that it is A intersection B intersection A complement. Then now you've seen this complement we wrote here. Since this is one set and we are subtracting that set, we are going to write the complement here on the outside. When we do this, we can distribute the complement with everything that is in this set, which means that we are going to have A intersection, then the complement multiplies with a B, and then it's going to become B complement. Then the complement multiplies with the intersection, it changes, it becomes union. Then the complement multiplies with the A complement, becomes A. Okay, as a result, you are going to have this. Then when you reach this point, you are going to do what? You are going to distribute the what? The A intersection. As a result, you are going to have A intersection B complement, meaning you are going to have A intersection B complement, okay, union A intersection A. Okay, we are going to have that. So here when we have something like this, it is just the same as writing it as A intersection B complement union A. Okay, that is what we have, because A intersection A is just the same as what? As A. So now when you reach this point, the easiest way, it is just to create what? A Venn diagram. Okay, since you have two sets, and these sets are involving you have two types of sets. You have set A and set B. So I'll draw a Venn diagram that is going to have A and B. Okay, A and B. Then now I'll use red. So now they are saying that, let me start with A, since I'm unionizing it with this one. I'm going to start with A intersection B complement. A intersection B complement, it means that it is everything, it is A, everything that is in A except what is in B, meaning that it is this part which is here. Okay. Now, they want us to unionize it, meaning that they want us to put it together with, in this case, so this is A intersection B complement. Then now let us see what A is. So AB. So when they talk about A, they mean everything that is in set A. This is set A. Okay. Now they tell you to unionize. When they want you to unionize, they're simply saying putting them together. So when you're putting these two things together, you are going to realize that when you put them together, you are going to get what was shaded here, and you're also going to include this part because you are putting together. As a result, you're going to find out that everything here, you're going to shade the entire set, because this one only comprises of this part, and then now even this part now will also be shaded because of this part which is here on A. As a result, you find out that the entire of A is going to be shaded, meaning that our answer here is A. Are we together?
Yes, sir.
All right. So that is how you are going to be what? To be solving these questions. That's the easiest way. Now let us go to B, or to Roman numeral number 2. When you go to Roman numeral number 2, they want us to simplify this set. Complement union A minus B, like this. Okay, so now you're going to distribute the complement with everything here because you want to break the brackets which are here. So when you multiply the complement which is here with everything, you're going to have the complement multiplies with this. It's going to become, because this complement is for this entire set, so it's going to be complement, and this complement you're going to have A intersection B. Okay, then the complement will go because they're going to cancel. Then complement times union is going to become intersection. Then complement times this is going to become A minus B with a complement outside. Now when you reach this part, you're just going to say, okay, here I have A intersection B. So I'll have A intersection B. It will be intersecting with, I'll simplify this further to say that this is the same as writing it as A intersection B complement with a complement outside. Then I'll simplify this further to say I'm going to have A intersection B, okay? A intersection B intersection A, okay? Intersection A, so this is going to be complement times A is going to be A complement. Complement times intersection to become union. Complement times B complement to become B. Okay, so when you reach this part again, you can check the inside. Do we have an A intersection and A intersection on both ends? We don't have. So the easiest way again you can do this is to distribute. Okay, you can distribute A intersection B with these components which are here. By doing this, you're going to have you'll get the A intersection B, okay, the entire of it. Then you intersect it with the first one, okay. Then that will be the first one. Then you're going to say, since here there is union, okay, you're going to say union. Then you say A intersection B, you intersect it with what? With the B. You are going to have that. Okay, so you can just arrange the things in order. You're going to have A intersection A complement intersection B. Okay, that's what you're going to have. Then union, this is going to become A intersection B, because B intersection B is just what? Is just B. Okay, you're going to have that. Okay, so now we have A intersection A complement intersection B. So we have A intersection A complement intersection B. That is what we have this side, union A intersection B. Okay, that is what you have. Now, A intersection A complement, not this. A intersection A complement is just an empty set. Okay, then A union A complement is the universal. Remember these rules? Hello? Okay. So, meaning that we have, so if you're not able to get me, feel free to just tell me that you're not able to get me because I'm not in the call. I'm presenting. So, feel free and be responding when I ask you so that we can, I can be getting feedback. So from here, this tells us that since we have A intersection A complement, we are going to have empty set this side, intersection B. Okay, union A intersection B. Now, when you intersect a set with an empty set, the answer is just empty set. Okay, unionize it with A intersection B, you're going to have A intersection B, because you are putting together, you get this set and you add the empty set, you are just going to have A intersection B as your final answer. Are we together? All right. Now, let us go to another question. So, our next question is telling us that yes, so it is saying that the equation 4x squared plus 8x minus 1 is equals to 0. It has roots alpha and beta. Then the first question is telling us find the values of alpha to the power 3, beta plus alpha beta to the power 3, and then here we have and alpha to the power 3 beta times alpha beta. Okay, that is what we have as our what? As our, yes, we have this. In short, let me just say we have this, and these are the values. They want us to find the values of these. Okay, they want us to find the value of alpha to the power 3 beta plus alpha beta to the power 3 and alpha to the power 3 beta times alpha beta to the power 3. Okay, so it's more like they want us to find the sum and the what? And the product. Okay, so and the next one is telling us to find an equation whose roots are alpha to the power 3 beta and alpha to the power alpha beta to the power 3. Okay, so our first question, so the first thing, okay, before you even start solving the question, the first thing you're supposed to do, it is to find the sum. You have been given an equation, okay, and they're telling you that this equation they've given you, the roots of it are alpha and beta. Okay, so what you're going to do is that you have this equation which is 4x squared plus 8x minus 1 is equals to 0. That is our what? That is our equation, our quadratic equation. Now, when you're finding roots, roots are only just solutions. Okay, like I said in the previous videos, roots are just equation or solutions. So in this case, when you have roots, they are saying that alpha and beta are the what? Are the roots. So these roots, when you add them, alpha plus beta, you're supposed to get negative b over a. Then when you multiply them, which is the product, you're supposed to get c over a. Now, what is our a? In this case, our a is just 4. Okay, what is our b? Our b, it is 8. What is our c? Our c is negative 1 from a quadratic equation. Don't forget this. That is how a quadratic equation is. So now, you have identified what a is, you have identified what b is, you have identified what c is. Now, let us find the sum. So this is the sum, okay? You can say sum, and then this is the product, like this. Okay, so for the sum, you say it is negative b, which is negative 8, over a, which is what? Which is 4. As a result, we are going to have negative 2. That is the sum of these two roots of this equation. Then now, what is our product? Our product, it is c over a, which is just negative 1 over a, which is 4. As a result, it is just negative 1 over 4 as our what? As our product. So these two are this one is the sum, okay, and this is the product. Now, after you've solved this, now you go to the question they're asking us to do. So the question is asking us to find they're asking us to find alpha to the power 3 beta plus alpha beta to the power 3. Okay, that is what they're asking us, and we are also supposed to find, this is for I, okay, and then you're also supposed to find alpha to the power 3 beta, okay, times alpha beta to the power 3, which is the product. Okay, you can see yourself. This is the sum, and this is the product. Now, when you reach this part, what is the sum? Let us first find the sum. So we have been given alpha to the power 3 beta, then plus alpha beta to the power 3. Okay, so if I just double check, that is what we've been given. Yes. Okay, so now for us to solve this, we need to have alpha plus beta, because it is what we know. Because alpha plus beta, we've gotten it to be what? To be negative 2. Okay, that is what we know. And we also know alpha beta. We don't know all these things of alpha to the power 3 beta. We don't know all those things. But what we know, it is this. Okay, so we need to find a way that we can have alpha plus beta in this expression. How are we going to have that? So here you are going to find the factors. Okay, the factors. Let me just say what is common here. It is alpha and beta. So you are going to say alpha and beta are what? Are common. Then you are going to say alpha beta into alpha to the power 3 beta, which is going to give you alpha squared. Okay, then you're going to say plus alpha beta into alpha beta to the power 3. It's going to give you beta to the power 2. Okay, that is what you're going to have. Now, you know what this is, but you don't know what this is. So you need to find what this is. Okay, how are you going to do that? This is what you're supposed to do. You need to have this, because this is very alpha squared plus beta squared. You don't know that. You only know alpha plus beta, but you don't know when they are squared. You don't know them. So what you're supposed to do is that you create to say, how can I get to have alpha squared plus beta squared? I can only get this in an expression when I say alpha plus beta when I square it. I am going to get alpha we'll multiply with everything, okay? Or let me just do it step by step so that others who are not able to do it. So you have alpha plus beta, okay? Again, you're going to have alpha plus beta. That's what it says when you have this expression. Then you're going to say this is the same, alpha is multiplying with everything that is here, which is going to have alpha squared. Alpha times beta, you're going to have plus alpha beta. Okay, beta times alpha, you're going to have plus alpha beta. Then beta times beta, you're going to have beta squared. Okay, and then here you have alpha plus beta, which is squared. Then now here you're going to have alpha squared. Okay, you bring the beta squared because that's what we are looking for. Then these two are going to add. You're going to have 2 plus 2 alpha beta, okay, is equals to alpha plus beta squared. So now you want this component, which is here, okay, because you want this component, you're going to take this one this side so that you can find the value of it. When you take this one this side, you're going to have alpha plus beta squared is or minus 2 alpha beta, because when it goes this side, it's going to become negative, is equals to alpha squared plus beta squared. When you have this, you have solved the inside. You've solved alpha squared plus beta squared, because alpha squared plus beta squared is just equals to alpha plus beta, which is squared, minus 2 alpha beta, meaning that where there is this component, you're going to replace there with this, because this you can calculate for, okay? Okay, are we together up to this point, everyone?
Yeah.
All right. So when you reach this part, now you're going to replace this component here on the inside. As a result, you're going to have alpha, you're going to have alpha beta, okay? The inside we had alpha squared plus beta squared. That's what we had. As a result, we are going to have alpha beta. Then here on the inside, you're going to replace it with that one which you've gotten now, which is alpha beta squared minus 2 alpha beta. Okay, that is what you have. So when you do that, you've replaced. Now you already know what alpha plus beta is. Okay, alpha plus beta is negative 2. Alpha beta is negative 1 over 4. So what you're just going to do here, you're going to start replacing. Okay, here you have alpha beta, so you're going to replace with what? You're going to replace with negative 1 over 4 here. Okay, then you're going to open the brackets. These are the main brackets. So let me just differentiate a bit on the brackets. So that you don't get confused. So here we have this. Okay, because we have an inside bracket, so let's do that. So we have this on the outside. Then you're going to open the brackets. Then here we have alpha plus beta, which we know that it is negative 2. It's going to be squared, minus 2. Then alpha beta, you know that this is what? Negative 1 over 4. Okay, then you do that. When you do that, you're going to have negative 1 over 4. Okay, so when you break this these brackets in here, you're going to have inside you're going to have negative 2 squared is going to be 4. Then negative 2 times negative 1 over 4, it will give you plus 1 over 2. Okay, so when it gives you that, you're going to have negative 1 over 4. Okay, it will be multiplying with 4 plus 1 over 2, which is just 4 over 1 plus 1 over 2, which is just going to give you 2. And then 1 into 2, it is 2. 2 times this, it's 8, plus 2 into 2, it is 1. 1 times 1, it will be this, then it will be 9 over 2. Okay, so here it's going to be 9 over 2. Then when you reach this part, you multiply, you're going to have negative 9 over 8. So meaning that the sum is what? Is negative 9 over 8. Are we together? Is everyone there?
Yes, sir.
Okay, so that will be your sum. Now the question was asking us to also find the product, which was alpha to the power 3 beta times alpha to the power alpha times beta to the power 3. Okay, that's what it was also asking us to find. So what we're going to do, we're going to say, now let us find alpha to the power 3 beta times alpha to the power alpha beta to the power 3, like this. So here you just multiply. You're going to have this one is multiplying with the alpha, it's going to be alpha to the power 4. Then the beta with the beta is going to be beta to the power 4. As a result, you can just factor out the alpha and the beta, or the 4. As a result, you're going to have alpha beta to the power 4. Then alpha beta, you already know what it is. Alpha beta, note that alpha beta is equals to negative 1 over 4. So hence, you are going to say this is equals to alpha beta, it is negative 1 over 4 to the power 4. Therefore, it will be equals to negative 1 over 4 to the power 4. It is just 1 over 16. Okay. And that will be your product. Are we together?
Yes, sir.
Okay, so that would be the first question. So you've seen it was involving. So I've taken time because I wanted you to understand on the principles they were using to solve this. So you can check the next question they're asking us. Is saying find an equation whose roots are alpha to the power 3 beta and alpha beta to the power 3. Okay, so you've seen that it's just the same things what we're doing. So when they tell you to do this, in case they don't tell you to do this at the start, you have to do what we have already done. Okay, when they just tell you this, you have to first find the sum and the product, then you find the new equation. Okay, but in this question, since they had already given us these same new roots, because this is just this, you can check here. Okay, and then this is just this which is here. So now we've already added them, we've already multiplied them. So meaning that the next thing is just to find what? The new equation. Okay, so in this case, we are going to say that on 2, when finding an equation, you say that x squared minus sx plus p is equals to 0, where the s is the sum, okay, the sum of the roots, and the p is the product of the roots. That is the formula. So from there, you're going to say that x squared, you already know what the sum. Sum we've already calculated for it, which is alpha to the power 3 beta plus alpha beta to the power 3. We got it to be what? To be negative 9 over 8. That is what we got, if we remember very well what we were solving here. Okay, that is what we got. So this is just telling us that, okay, we have our sum there, and then our product, it is alpha to the power 3 beta multiplying with alpha to the beta to the power 3, like this. We got it to be what? We got it to be 1 over 16. So it is 1 over 16. Then henceforth, you're going to say that in this case, it is going to be x squared minus what is the sum? the sum is negative 9 over 8. So you're going to say negative 9 over 8 x plus the p, which is just 1 over 16, is equals to 0. Then you're going to have x squared plus 9 over 8 x plus 1 over 16 is equals to 0. And that is your answer. So they'll mark you if you reach here. Okay, they'll give you 4 marks. Or what you can do is that you multiply with the highest number, which is at the bottom here. It's going to multiply by what? By 16. When you do that, it's going to give you 16 times 0, it will be 0. So yes, I'll say O. 16 times 0, it is 0, is equals to 16 times 1 over 16 is going to give you 1. 16 times 9 over 8x, it's going to give you 18. Okay, it will give you, oh, not 8, it's going to give you, so 8 into 8, it's 1, 8 into 6 is 2, 2 times 9 is going to give you 18, yes. 18x plus 16 times this, it's going to give you plus 16x to the power 2. And this, so you can give either answer. Okay, it will still be correct. Are we together, everyone?
Yes, ma'am.
All right. So that is how you solve this question. Okay, we have another question. So our next question on this, we are being asked to say that given that the square root of 2 is irrational, show that square root of 2 plus 3 is what? Irrational. So when they give you this question, you need to understand that the method they want to use, it is proof by what? Proof by contradiction. So what you're going to say is that if you say proof by contradiction, they are telling us that the square root of 2 plus 3 is irrational. So us will assume the opposite. Okay, so we're going to say that let us assume that the square root of 2 plus 3 is what? Is rational. That is what we are going to assume. So square root of 2 plus 3 is what? Rational, which is opposite with the statement they've given us. If it is rational, because remember that rational numbers are numbers that can be represented as a over b, where a and b are integers. Okay, and they're in the simplest form. And b is not equals to what? To 0. Those are what? Rational numbers. So this is just telling us that the square root of 2 plus 3 can be written as a over b. Okay, where a, b must be members of integers. Okay, and b here in the denominator, it must not be equals to 0. And a and b must have no common factors. And they've included another one. They've said that the square root of 2 is what? Is irrational. So, and square root of 2 is irrational. So you add it there. So when you do that, you're just going to say now you solve this equation here. As a result, you take the 3 this side because they're separate. You're going to have square root of 2 is equals to a over b minus 3. Okay, it was positive, so it goes inside, it becomes minus 3. Then you divide by 1. Okay, so here your common denominator is b. B into b, it is 1. 1 times a, it will be a. Then here 1 into b, it is b. B times 3, it's going to give you minus 3b. Then is equals to the square root of 2. Now you're going to identify that this is the what? The left hand side, and this is the right hand side. Now on the left hand side, it is what? Left hand side is this one. They've said that it is what? Irrational. So left hand side is irrational, and then the right hand side is rational. Okay, that is what we've identified. So if that is what we've identified, left hand side is irrational, right hand side is rational. How can this be? Okay, so we are going to write a statement to say that the left hand side is irrational.
Yes, sir, even me.
Okay, you can't see my screen?
No.
Okay. So the left hand side is irrational. Okay, while the right hand side, you're able to see that here the right hand side is rational because these are integers. You can subtract and then you divide by the b. These are integers, you get an answer, okay, which will be what? A rational number. So you can see that this side, the right hand side, is what? Is rational. This is what? This is impossible. Okay, this is impossible because irrational cannot be equal to rational. Okay, then you're going to say, therefore, by contradiction, square root of 2 plus 3 is irrational. So that is what you're supposed to do when you are given such a question. So there are different questions. Sometimes they'll ask you square root of 3. You also need to know how to prove all those things, because they can ask you whichever they want to ask you. Okay, are we together? Are we together, everyone? So you can just be responding because of I'm not in the call. It's keeping me updated. Are we together, everyone? Anyone with a question? We are not clear. Okay, now we move on to the next question. So our next question is asking us to say express 0.0810, okay, as a fraction in the form of p over q, where p and q are what? Integers. Okay, so when you're given this question, what you need to understand is that this expression, you're just going to say that let x be equals to this expression, which is 0.0810. Okay, bar. So when you let your x to be equals to this, you're going to say that multiply. So when you let your x to be equals to this, you're going to say that this becomes your equation what? Equation I. Then you're going to say that multiply I by okay. So when you let your x to be equals to 0.0810 bar, you make this to be your equation I, then you multiply the equation I by, so we're going to multiply by a certain number, okay, and what is going to be determining the number we're multiplying with is something that is here. So you're going to check that are all these numbers repeating, okay. You're going to realize that the only numbers which are repeating, it is 810. So meaning that here the next one is going to be 810, but the 0 which is in front here is not repeating. So what you're going to do is that you're going to multiply this equation by a 10 first, so that you can remove this number, or yes, this number which is not what, which is not repeating. So I'll multiply I by 10 so that I get what? So to get 10x is equals to 0.810 bar. So when I do this, this becomes my equation 2. Okay. So now this equation 2 I have gotten, I am going to multiply it. Multiply 2 by how many numbers are here which are repeating? 1, 2, 3. So you're going to say 1, 1, 2, 3. Okay. To get, so it's going to be 1000 times the 10, it's going to give you 10,000. X is equals to 1000 times this is going to give you 810 point, okay, 810 bar, and this becomes your equation 3. Okay, now when you get your equation 3, you're going to subtract 2 from 3. So you're going to have your 3, which is 10,000 x, okay, is equals to 810.810 bar, okay, and you're going to subtract with the 2, which is 10x, okay, which is equals to 0.810 bar. Okay, so when you subtract, you're going to get this and this. So it's going to be 10,000x minus 10x is going to give you 9990. Okay, 999, which is 9,990. X is equals to, when you subtract, you're going to get 810, because it's going to be 10,000 minus 10x, then 810.810 bar minus 0.810 bar, and you're going to get 810 as your answer. Okay, then you're going to divide by 900 or 9,990, even this side by 9,990. As a result, your x is going to be equals to 810 over 9990. Then your x is going to be equals to, remove the 0, you're going to have 81 over 999. So the number that can enter into this and this, it is what? It is 9. So 9 into 81, it is just 9. 9 into 999, it is 111, and this becomes your answer. Are we together?
Yes.
Okay, so that would be your answer. Okay, so is there another question? I'm hearing a sound of a question. Someone is raising a hand. You are free to ask.
Yes, sir.
Yes.
What if you left it on 81 over 999? Can they mark?
Yes, they can mark. That's actually the number, but they just want you to reduce it. So maybe you can lose a mark just to say maybe because when they are marking mathematics, they mark in portions. For when you reach here, there's a mark. When you reach somewhere here, there's a mark. There's a mark. So you can just maybe lose a mark for not reducing. But most of the times when you just reach somewhere here, because you've almost solved it. Because even this is an integer. Even this is an integer. So even if you leave it like that, it will still be correct. So, but just for the sake of, but there are numbers which cannot be reduced, so you can just leave them like that. Okay, so that is something that you need to put in mind. Okay, are we together?
Sir, can you repeat again, please?
All right. So when you reach a point, for example, you are here, x is equals to 810 over 9990. So because of time, you might not start thinking of numbers where you can reduce it like that. Others will just leave it here. They'll still mark you to be correct, okay, because all the people have encountered writing just like that without like simplifying it further. They get the full marks, okay. But my advice is just make sure that you also reduce it if you're able to see the reducing number. But if you're not able to see it because you only have less time, just leave it the way it is. Go to another question because you've solved it. Okay, that's my honest advice and opinion on this issue. But I would advise you to reduce it further. Clear?
Yes, thank you.
All right. So now let us solve another question. This question is telling us simplify 3 minus 2 the square root of 2 over square root of 2 minus 1, giving your answer in the form p plus q the square root of 2. Okay, so here you have this question. So you have 3 minus 2 square root of 2, okay, over the square root of 2 minus 1. Okay, that is what you have. So they want you to write it in this form where you have p, which is just a number, and q is a number which is attached to what? To the square root of 2. So what you need to do when you have this question, the first thing is that you do what? You rationalize the denominator, okay, because you want to put it in this form, because if you try to solve it like this here, it might be difficult. So you're going to rationalize the denominator by saying times. You get the denominator and multiply by the conjugate on top. Okay, on top you multiply with the conjugate, which is square root of 2 plus 1 over square root of 2 plus 1. Okay, so when you do that, you're going to have here at the bottom, you are going to have a difference of 2 squares, which you can just multiply square root of 2 and square root of 2, which will just give you a 2. Then minus times positive, it will give you minus. 1 times 1, it will give you 1. Then on top, it's going to give you, you get the 3, okay, and multiply with everything that is here. Then you get the minus 2 square root of 2, and you multiply with everything that is here. Okay, as a result, you're going to have 3 times the square root of 2, it will be 3 square root of 2. 3 times 1, it will be plus 3. Then negative 2 square root of 2 times the square root of 2, it is going to give you minus 2. Then the square root of 2 and the square root of 2, they are going to break the square root, and you're going to have a 2. Okay, like that. Then negative 2 square root of 2 times positive 1, it's going to give you minus 2 square root of 2. Then at the bottom, you're going to have 2 minus 1, which will just give you a 1. Okay, then when you reach here, you're going to say that, okay, they want me to write it in this form, so I'll just get the like terms together, which I have. So here, let me start first by saying 3 square root of 2 plus 3. Then this is going to give you minus 4. Then this is going to give you minus 2 square root of 2 over 1. Okay, so when you reach this point, you're going to say that, okay, they want me to put it in this form, so meaning that I'm going to have 3 minus 4 plus 3 square root of 2 minus 2 square root of 2. Okay, over 1. The 1 is just, let me just write it there before I remove it. So 3 minus 4, it's going to give you negative 1. Then positive 3 square root of 2, 2 square root of 2, it is going to give you plus the square root of 2. Why? Because this square root of 2, you can take it as if it is just maybe to say it's x. So it's like 3x minus 2x, it will just give you what? It will give you x. As a result, that x is what? Is square root of 2. So as a result, that is why I've written like that. So over 1. And then this is going to have 1 into this, going to give you negative 1 plus 1 into this, it is going to give you the square root of 2. And this is the answer, which is in the form of p, which is negative 1, plus q square root of 2, which is square root of 2. Here there is 1, which is q. Okay, and there you have your answer. Okay, are we together, everyone?
What about the q? Like,
so here the q,
okay.
Here when you have a number like to say square root of 2, here there's a number in front, which is what? It's 1. Okay, so meaning that the q, it is 1 in short.
All right.
Yes, and you have solved the question. Clear?
Yes.
Okay. Okay, so there's another question here. It's a modulus equation. Okay, so this question is saying that solve the equation modulus of 3x minus 5 modulus is equals to 11 minus x. Okay, so when you're given this question, what you're just supposed to do is that when you have 3x minus 5 in the modulus is equals to 11 minus x. So there are two methods on how you can solve this, but I would rather you use using this method. You're going to square both sides. Okay, when you square both sides, you're going to remove the modulus. Okay, meaning that you're going to have when you square this side and also square this side, meaning that here you're going to have yes, so it's more like the modulus is going to multiply with the modulus. Okay, as a result, you're going to have 3x minus 5 multiplying with what? 3x minus 5 is equals to 11 minus x squared. Okay, are we together? Oh.
Open your screen.
Okay, so when I square both sides, what I'm going to have, let me just write it like this. When I square the modulus, it's like I'm going to have modulus of 3x minus 5, again another modulus of 3x minus 5, okay, is equals to 11 minus x. Oh, don't know why I'm doing this. So it's going to be like this. Okay, 11 minus x. So here it's just the same. The modulus are going to break when you multiply them. You're going to have 3x minus 5, okay, multiplying with 3x minus 5, okay, is equals to 11 minus x. Again, 11 minus x. So when you reach this part, you're going to multiply 3x times this. So it's going to be 3x is multiplying with everything that is here, which is 3x, okay, minus 5, and then this one here, the 5 is going to be minus 5, 3x minus 5, okay, is equals to 11 minus x, then minus x, 11 minus x. Okay, as a result, you're going to have 3x times 3x going to give you 9x squared. 3x times negative 5 is going to give you negative 15 x. Then negative 5 times 3x is going to give you minus 15x. Then negative 5 times negative 5 to give you plus 25 is equals to 11 times 11, 121. 11 times negative x, it will give you minus 11x. Negative x times 11, it will give you minus 11x. Then negative x times negative x to give you positive x squared. Okay, as a result, you're going to have 9x squared. Okay, 9x squared minus 30x plus 25 is equals to 121 minus 22x, then plus this one here, which is plus x squared. Then as a result, you're going to take all these, which is this side. As a result, you're going to have 9x squared. The x squared, it's positive, and comes this side, going to be minus x squared. Then you're going to say minus 30x. Then the negative 22, when it comes this side, is going to give you plus 22x. Then you're going to say plus 25. Then the 121, when it comes this side, is going to give you minus 121 is equals to 0. Okay, so as a result, you're going to have 8x squared. Then this is going to give you minus 8x. Okay, then this is going to give you 25 minus 121. It's going to give 121 minus 25, and then this is going to give you 6. Okay, 96. So it's going to give you 96. So it's going to be negative 96 is equals to 0. Okay, so now when you have that, you have 8x squared minus 8x. Okay, and then minus 96 is equals to 0. What you can do here is that you've seen that there's a common number that can be divided into all the numbers, right? Which is what? Which is 8. So you can divide this by 8 so that you solve it in a simple way. When you divide by 8, you're going to have 8 into this, it's going to give you x squared. 8 into this, it's going to give you minus x. 8 into this is going to give you minus 12 is equals to 0. Then here, what's my product? My product, I'll get it by multiplying 1 times negative 12, which will be negative 12. My sum is equals to negative 1. My factors, two numbers, when I multiply them, I am getting negative 12. When I add them, I am getting negative 1. Those two numbers are negative 4 and what? And 3. Okay, are we together up to this point, everyone?
So can you go back to the second slide? I stopped seeing your screen. Within this 121 is going to be. Alright, thank you, sir.
Alright. So we are going to have that. So here, when you're solving using factorization method, I'm sure you know how to. For those who don't know, I will explain. Yes. When you're solving quadratic equations using factorization method, what you do is that you find the product to multiply the a with a c. Okay, in this case it's 1 times negative 12, which is what? Negative 12. For the sum, you get the number that is with x, which is negative what? Negative 1. There is an invisible 1 here, negative 1. Then for your factors, it is negative 4, 3. Okay, two numbers, when you multiply them, you get negative 12. When you add them, you get negative 1, which is what? Negative 4 plus 3, it is negative 1. Negative 4 times 3, it is negative 12. So those are your factors. As a result, you're going to say that, in this case, you're going to say that, okay, I have my factors. I'll just say x squared, which is this one here. I'll say minus. I'll get the factor here, which is minus what? Minus 4. So I'll just get the factor, which is negative 4. Then I'll add the x. Then I'll get the other one, which is positive 3. Then I'll just add the x. I'll replace it on this component here. Okay. So when I replace it there, I'll say minus 12 is equals to 0. Then I'll factorize to say, okay, here and also here. Here what is common is x. X into x squared, it will be x. X into negative 4, it will be minus 4, because x into minus 4x, it will be minus 4x. Then what's common here is positive 3. Positive 3 into x is going to give you, into 3x, it's going to give you x. Positive 3 into negative 12, it will give you minus 4. Okay, is equals to 0. Then you get what is outside, x plus 3, and get what is inside, which is x minus 4, and you equate it to 0. Hence, x plus 3 is equals to 0, and then x minus 4 is equals to 0. Then your x is equals to negative 3, your x is equals to positive 4. Okay, so if you get these answers you've gotten, you just don't get them like that. You have to test them in the original function, which was 3x minus 5 is equals to 11 minus x. It has to give you the same answer for both sides. Okay, if it doesn't, that solution, you reject it. So we are going to test negative 3. When I plug in negative 3 on this component here, we're going to get negative 3 minus 5, okay, is equals to 11 minus negative 3. Okay, then this side I'm going to get 3 times negative 3 is going to give me negative 9, minus 5, it will give me that. Okay, then this side is going to give me 11 plus 3. Then here I'm going to get negative 14, okay, is equals to 14. Then here I'll have the absolute value of negative 14, it is 14, is equals to 14. So negative 3 is a what? Is a solution. Okay, are we together?
Yes, sir.
Yes, so this one is a solution. Then now we now test the other component, which is the 4, okay, which are going to say that, okay, we have 3x minus 5 is equals to 11 minus x. So you get the 3, you're going to have modulus of 3, then you get the 4, you plug in there, minus 5 is equals to 11 minus 4. Okay, so you're going to get 12 minus 5, okay, is equals to 7. So 12 minus 5, it will be 7, okay, and then it goes to 7. So 7 is equals to 7. So both of them are what? Are solutions. So you just say, therefore, x is equals to negative 3 and x is equals to 4. So, and you are done with the question. Okay, are we together?
Yes, sir.
All right, so sure, by now it's 21. Okay, so we are going to end